Show by counterexample that the statement here is false, and find all the values of theta between 0 and 360, satisfying this equation here. So I've copied down the questions. So let's have a go at these then. Let's try theta equals 0 for A and see what we get, because that's an easy value to put in. Theta equals 0 gives, so cos 0 and cos 0 is 1 plus 1, which is 2. And cos 0 and cos 0 again will be 1 times 1 times 2 equals 2. So that's not a suitable value. So let's try another one. Try theta equals 90 degrees then, see what we get. So cos 90 is 0. Cos 270 is also 0, isn't it? Is that equivalent then to cos 180, which is minus 1? And then cos of 360, 490 is a 360, cos 360 is back round to cos 0, which is 1. So this is minus 2, so, which is not true. 0 is not equivalent to minus 2. So there's our counterexample. Okay, so that's part A done then. So that's false. So part B now, let's turn our attention to that. We've got this trigonometric equation here. We're solving between 0 and 360. We've got cosec here and cosec squared, so we need to change this to cosec squared theta, don't we? If we remember here, let's just remind ourselves, sine squared plus cos squared equals 1. So cot and cosec squared then, if I divide by sine, we'll have 1 plus cos over sine is cot, and 1 over sine squared is cosec, isn't it? So there's the thing we need. So we can replace the cot squared by cosec squared theta minus 1. So let's do that then. Now we've reminded ourselves of the formula. So here, this is part B. Here, cosec squared theta minus 1, that was what the cot squared equaled, minus the 9 is equal to cosec theta minus cosec squared theta. Move this minus over to be this with this cosec theta to make 2 cosec theta squared. And then we've got this cosec, move it over here to the left to be minus cosec theta. And then numbers wise, we've got a minus 1 and a minus 9, which is a minus 10. There's nothing left here on the other side, is there? Now hopefully we can factorize this, 2 cosec theta and cosec theta. There's not a lot of choice there. Now it's either 10 ones or 5 2s. 5 2s looks promising because you get a 4 and a 5 and the difference will be minus 1, provided that's the minus and that's the plus. So that looks fine. 2 cosec, of course, theta. 2 cosec squared is that term. Plus 4 minus 5 is minus 1 cosec theta. And then we get the minus 10, don't we? So this tells us then that cosec theta is equal to, what would this be? 5 over 2. And this one tells us that cosec theta, which I'm determined to write as cosec theta equals minus 2. So let's turn our attention to solving these now. So cosec is 1 over sine, so let's invert the fraction, is equal to 2/5. And this one is sine theta is equal to minus a half, isn't it? So solve this one. So draw a circle, right cast. Sine is positive here and here. Draw 2 lines. Mark off alpha, the associated acute angle, to the horizontal, and simply write sine alpha equals this value and drop a minus if there is one to drop. Alpha is shift sine of 2/5 or 0.4. We need to be in degrees mode, so let's make sure we are. Yep. So shift sine of 0.4, wasn't it? 2/5. 23.6 degrees. There's alpha. And so we can read off the solutions. The first solution is round to here. Theta is equal to 23.6 degrees. And the other solution is right round to here, which is round 180 back 23.6 degrees, which is 156.4 degrees. So there's the two solutions from that one. Now let's turn our attention to the other problem. So draw a circle again, right cast. Sine is positive here and here, so it's negative there and there. So sine is negative. Draw two lines, mark off alpha, the associated acute angle to the horizontal, and write sine alpha equals a half. We know that alpha is 30 degrees in that case, don't we? So alpha is 30, so the one solution is round to here, which is 180 plus 30. So theta is equal to 210 degrees. And the other solution is if we go right around to here, which is round 360 back 30, which is 330 degrees.